Okay. Hello guys, welcome to the lesson of DBA from Introduction to Practice. I'm your old friend Peng Wang, the global technical evangelist for OceanBase. Through the previous course introduction, everyone already knows how to deploy and use OceanBase and understands some of OceanBase's features, right? Today's lesson is mainly to help everyone use OceanBase's diagnostic tools to diagnose and tune OceanBase. Let's get started. This lesson content includes the first one, Introduction to Agile Diagnostic Tools. And the next is use the obdiag tool for self-diagnosis. Next is add obdiag diagnostic scenario by yourself. And the last chapter is Agile Diagnostic Tools Summary and Outlook. Before introducing the Agile Diagnostic tool, let's first talk about the classification of OceanBase questions from the work orders we handle, from issues, and user feedback. We can see that the types of faults can be divided into two categories. They are theoretical questions and non-theoretical questions. Theoretical questions include partly right theoretical, slow theoretical, and abnormal theoretical. Non-theoretical questions are more numerous, such as disk I/O, memory, CPU, network problems, readable cluster configuration, host configuration problems, merge dump problems, and others. The diagnostic tool which introduced to you is obdiag. obdiag is an open source Agile CLI diagnostic tool. The existing functions of obdiag, including scanning, collection, and analysis of OceanBase's logs, SQL audit, and OceanBase process stack-trace information. It can be executed with one click in different deployment modes of the OceanBase to complete the collection and analysis of diagnostic information. Next, let's introduce how to use the obdiag. Before introducing obdiag, let's revisit how our engineers typically communicate with users to resolve issues. This involves a lot of repeated communication to clarify the problem, right? And it's requiring user to collect data on different nodes, and then download and run different scripts or tools to upload the missing data. The method consumes a lot of time and energy. Based on this situation, OceanBase launched the obdiag tool, which greatly simplified the process. Through four functions, we can quickly and conveniently obtain the information we need to collect and then quickly locate and solve customer problems. We will soon provide a detailed introduction to these functions for everyone. As we just mentioned, obdiag is an open source Agile CLI diagnostic tool. It has the following four characteristics. They are extremely lightweight. And second is easy to use and fully open source. The last one is highly scalable. And obdiag has four core functions. The first one is one-click cluster inspection. It supports one-click cluster health inspection for more than 30 inspection items. The second one is one-click analysis. The next is one-click root cause analysis. The last one is one-click information collection. Support one-click information collection for more than 24 scenarios. Next, we will introduce the installation method of obdiag. There are multiple installation methods to choose from. The first method is to use yum install obdiag online independently. The second method is the offline independent installation. The last one is installed obdiag using the OBD method. If your OceanBase cluster is deployed with OBD, and you can also use the OBD to install obdiag. Next, we will use this command to configure obdiag. This parameter that needs to be filled in this command are the information of your OceanBase cluster, including IP and username, password, and also port. The following is the demo for you to refer to. Please note that for cluster deployed by OBD, there is no need to generate additional configuration files when using obdiag. You can directly use the function. OBD will be responsible for generating the configuration of obdiag. If we want to manage multiple clusters, you need to generate multiple cluster configurations. When using obdiag, simply specify the corresponding cluster configuration. Next, I will introduce the first function item of obdiag, one-click cluster inspection. The inspection content includes a lot. This command, obdiag checklist, is used to display the inspection content. For example, the obdiag check command will go to check all tasks without filter. When the user environment is a specific step, such as a Stitchbench environment, we can define parameters like Stitchbench run and Stitchbench free to collect the diagnostic tasks either during or before executing Stitchbench command. Next, we will introduce the second function, one-click diagnosis and analysis. This function is divided into two types. One is online analysis, and the other is offline analysis. Online means that obdiag has connected to the OceanBase cluster, while offline means that it's not connected to the OceanBase cluster. If it's an online analysis, we directly use the command obdiag analysis log, which will analyze the logs of all nodes in the last 30 minutes. We can also specify the time parameter after this command to analyze the logs within the specified time. If it's an offline analysis, we need to save all the logs of the OceanBase cluster in a folder first. Afterward, we can either specify the folder or specific files. When running this command, as the output result is shown at the bottom, If the status column shows parse, it means that there is no problem with the cluster. Here we show you the output of diagnosed obdiag finds errors. From here, you can see that the output of error code and the error message. Next, let's introduce one-click full-link diagnostic. There are tools in the case stage of the OceanBase execution process that help us collect data. When we execute one-click full-link diagnostic command, it will collect data from these tools. Let's take an example of one-click full-link diagnosis. The first step, let's find the trace ID of this cycle, and then in the second step, execute the obdiag analysis command to analyze the logs corresponding to the trace ID. Here is the output of full-link diagnosis command. The left picture shows the information output of the leaf node, and the right picture shows the detailed content. The specific content will also be saved in the file, and you can also view it in this file. Next, let's introduce the function one-click root course analysis. We can use the command obdiag rc_list to check the scenarios in this function. Supports. This kind of analysis scenario is updated very frequently. If we don't upgrade our obdiag, how can we obtain the latest analysis scenario? We need to use the command obdiag update, which can obtain the latest analysis scenario. By comparing the content of the two tables, this above table and the below table, we can see that after using the command obdiag update, we can obtain more analysis scenarios. The command to analyze a problem scenario is very simple. Just add the scenario name after the obdiag command. Here, we show you the output after executing the command. You can see from the output of this command, we'll print out the analysis results of each step. And we'll also give you a suggestion at the end. Next, let's introduce the function general diagnostic information collection. The information collection here includes two categories. One is the collection of log information. The other is the collection of various scenario information. As you can see in the table on the left, obdiag can collect various types of information, including logs of the entire cluster, cluster host information, execution information of the cycle with a specified trace ID, and select trace information and others. We can also collect all the information with one parameter. It's OR. Use this parameter. The figure on the right shows the printout when all the information is collected. Next, I will show you two examples. One is to collect stack trace information. The other is to collect plan monitor information. After stack trace information is collected, it will be stored in a compressed file, and the users can view it. The SQL execution information will be stored as an HTML file. Next, let's talk about the collection of scene information. This part is also very simple and convenient. The picture on the left shows that the list of scene information we support. User can select appropriate parameter values according to their own scenes. Collect scene information and then send it to our OceanBase technicians for analysis. So you can see that if there is a problem with the user's environment, the communication between the user and our technician is very simple and efficient. Let's look at how to add diagnostic scenarios ourselves in the chapter 3. The first function is obdiag update, which we just mentioned. You don't need to upgrade the version of obdiag. You can quickly update the scene with just this command, obdiag update. There are two ways to update. One is an online update, and the other is an offline update. After we complete the update, the folder will contain new and original theme files. Next, let's see how to add inspection items in an inspection scenario. From the file directory on the left, you can see that there are all the initial inspection items. Each YAML file is an inspection item. So how do we add inspection items? Let's look at two examples on the right. The first example is to add 𝘖𝘤𝘦𝘢 inspection item. The user can create a YAML file called 𝘖𝘤𝘦𝘢. The content of the file includes the SQL statement to execute the inspection, as well as the output result and error message. The second example is to add an AIO inspection item. This inspection item is to execute the SSH command, not the SQL statement. You can customize many inspection items according to your needs. You can also go to the official website to check the additional of other inspection items. Users can also customize the inspection scene, which is also very simple. You can see that the left side is our customized scene file, and the right side picture is the content of each scene file, including the type of operation to be performed, SQL statement, and other information. The last one is root cause analysis scenarios. The operation of this function is a little more complicated and requires the user to write some Python code. For example, you can create a scene analysis file in the file directory on the left. The picture on the right shows the content of the analysis file. After adding, we execute the command obdiag RCA list to view the scene analysis file demo we just added. The finally part is let's summarize the content of this lesson. The diagnostic and the tuning tool we introduced to you today is obdiag, as well as its main functions, specific operations, and implementations. You can use obdiag to troubleshoot problems in your production environment. First, use the one-click inspection function to find the problem print, and then use the log analysis and root cause analysis functions to narrow the scope of the problem. Finally, if you encounter some problems that you cannot solve yourself, you can also collect the problem information and then send it to OceanBase technicians to solve it. In our GitHub community or Discord community, our technicians will help you to solve this problem. Let's look at the obdiag plans. SQL diagnoser capabilities will be implemented in obdiag to complement obdiag's SQL diagnostic capabilities. Rely on one-click inspection to discover problems. Use one-click collection to obtain diagnostic snapshots, and focus on rule-based analysis modules to quickly diagnose the database. This page is a roadmap for obdiag development. We currently release a new version every month. In the future, in addition to introducing SQL analysis, there will also be exploration in AI. You can check it out after this lesson for more details. This is the open source content of OceanBase. The OceanBase address is on GitHub. In addition to open sourcing the OceanBase kernel code, we have also made the code for several peripheral tools available as open source. This includes the deployment tool OBD and the graphical developer tool ODC, and also has the diagnostic tool obdiag. You can go directly to OceanBase GitHub community to view the detailed open source information. Okay? If you have any questions about today's lesson, now is the perfect time to ask. Okay. Before we wrap up, I'd like to remind you our next lesson will be held next Thursday evening. It will be our last lesson, and we will dive into OceanBase's high availability architecture and discuss talent development. We look forward to seeing you then. You can also reach out anytime through our OceanBase, GitHub, or Discord community for further assistance. We are always here to help. We will be sharing how you can access the course materials and today's presentation slides in the comments section of this video. All the resources are free. Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye-bye.